Okay. Hello, everyone. Uh, I think we should start our training seminar now. Okay. Uh, it's me again. My name is Yang. Okay. This is our second time online tracking and product introduction. Okay. This day we are talking about the inverter. Okay. Felicity provides two types of inverters. One is high frequency and one is low frequency, or we can call it power frequency inverter. Okay. And first, let's introduce the high frequency inverter. And now we have previously we have IVCP and IVCM, and now we have the IVEM. Okay. Later we'll introduce the difference between these different products. Okay. And this is the application diagram. So this is the connection of the system. Okay. And here's the IVCP. IVCP is the building is PWM. P is PWM controller. And here now we are most selling. We have different models, but now the most selling mode is IVCP 1 kilowatt 12 volt. This one IVCP 1012 and IVCP 3024 means IVCP 3 kilowatt 24 volt. This is the most selling in recently. Okay, and is IVCM. IVCM, we also have different power of the models, but the most selling is IVCM 3 kilowatt, 3 kVA and 5 kVA. IVCM 3 kVA 24 battery is 24 volt and 5 kVA is 48 volt. Okay, and IVCM series is the building is MPPT. Okay, here you can see the PV here. Max PV area open circuit voltage means the PV input voltage. This is maximum, like IVCM 5 kVA is 145 volt. It's maximum input. But IVCP, you can see here, the maximum is 105, and the duration is from 60 to 72. Okay. And next is the IVEM. IVEM is the new design. Is from the function is more powerful. And first is like this one, like the PV input. PV input here. This is our first version. First version PV input maximum voltage is 450. Like IVCM, as you see, is 145. This one is 450. But now currently we already upgrade this mode, upgrade to 500 volts. Okay, 500 volts. PV input 500. Okay, and the advantage of the high voltage input is you can use less parallel, and single string you can have more pieces, and then you can from the system installation you can save more materials, and also the panel's efficiency is higher. It can be higher. Okay, and here is I made a conclusion to versus all these different of the models like IVCP, IVCM, and IVEM. Here, as you see, PV input range. The IVCP is the most narrow, and the IVEM is most wide. It's 500. Then this one only like only 60 to 70 this range, but this one can up to 500. Okay, and IVCM is 145. And from the controller is also different, as I said, PWM, MPPT, and MPPT. Okay, efficiency And of course, the building MPPT controller is higher than PWM controller. Okay, and this one is also the the biggest difference between IVEM and IVCP IVCM. This one is battery connection. IVEM battery is optional connection. Means if without battery, IVM still can work in, but IVCP IVCM, the battery is compulsory. It must be have the battery group. Otherwise, the system cannot work, cannot running. Okay, and for the parallel connection, parallel quantity, IVM maximum to up to 12 piece. IVCM, IVCP only 6 piece. Okay, and BMS communication means the communication with the lithium battery. Felicity also provide the lithium battery, right? So between the inverter and lithium battery communication, now only currently only IBM can do this. Okay, and battery activation means if the battery is in the off mode, it's off, totally off. So if you connect with the IVM, IVM's got the power from PV or from the AC, and then it can activate the lithium battery. The lithium battery means the Felicity lithium battery automatically. Okay, so from these compounds, you can see here IBEM is more smart and more powerful than the IVCP and the IVCM. Okay, and here next part is let me introduce the parallel part. Means here this part parallel using. Okay, parallel is used for like in the home usage if you need to get a bigger system like our high frequency is only maximum one piece is 5 kVA, but now you need 10 or 20 even bigger. Okay, then this time you can parallel connection, or you need a three-phase system. Okay, then it also can get a three-phase system by parallel way. Okay, so first it is the IVCM parallel. The inverter can be used in the parallel with two different operation mode. First one is parallel operation single phase, right? This is single phase parallel up to 6 units. The support maximum output power is 24 means 30 kVA. And second way is the three phase, 4 units support in one phase maximum means each phase minimum is one piece, but maximum is 4 piece. But totally the system totally is 6 piece. Okay, so you can divide the 6 piece as you want. You can divide it as 3 to 1 or 2 to 2 or 4-1-1. Any group is fine. Okay. Here I mentioned only 4 or 5 kVA support parallel for the IVCM. Okay. And next is IVEM. IVEM is different. IVEM, as we said, as we see in the form, is the maximum units is 12 piece, right? No matter single piece or a single phase or three phase. Operation is single phase with up to 12 units. Okay, then the maximum is 60 kVA, and three phase same. Okay, and here only 5 kVA support parallel. For our IBEM, only 3 kVA and 5 kVA. Only 5 kVA can parallel connection. Okay, this is the single phase parallel connection. This is diagram. Okay, this you can check. You can find this diagram in the user manual. But later I will show you the installation steps. It will be more details than the user manual. Okay, and this is three phase. You can see here this one P1, P2, P3 means phase 1, phase 2, phase 3. And here this is the communication cable connection, parallel current sharing cable. This green one is current sharing cable. Okay, and this is, you can see here, I use the same battery group and select the different phase of the AC input, then output three phase, neutral L1, L2, L3. Okay. Okay, this is the high frequency. Then now is the power frequency, means low frequency. So our low frequency upgrade to IVPS and IVPM. Previously is this one, like this IVPM. And now it's become IVPS and IVPM. IVPM means the MPPT building. Okay, MPPT building means you can connect the solar panels directly with the inverter. You don't have to charge the battery by the MPPT charger, because this one already built in an MPPT charger. Okay, and with the specification from zero from the five from 5 kVA IVPS 5 kVA to 10 kVA, you can find it. Okay, and here you can see IVPS is 10 kVA, like this one, both 10 kVA. IVPS 10 kVA, IVPM 10 kVA. Here, solar charge part. Here, this one. IVPS don't have. IVPM have these parameters. Solar input, PV input voltage, input power, and this one is charging current 120. So because only IVPM has the MPPT, built-in MPPT, so only IVPM can have these parameters. Okay. The power frequency or low frequency inverter also can parallel connection, and it's the same like the IVCP. The unit maximum is 6 units. Okay, and you also can parallel as single phase, like here, single phase or three phase is also same. Okay, but for here you notice only IVPS or IVPM 10 kVA support, means less than 10 kVA is not support the parallel. Okay, but IVPS and IVPM 10 kVA they can mix to parallel, means if you have a two-piece IVPS 10 kVA and two-piece IVPM 10 kVA, you can mix them to parallel. It's okay. Okay. This is a single phase, and here from the outside or the external connection is similar like the high frequency inverter. Okay, single phase. Okay, this is the current sharing cable and communication cable. This one, three phase parallel, P1, P2, P3. Okay, this is the similar like before. Okay, and here I make a form to list the differences between power frequency and high frequency inverters. Okay, here this one you can because for the installer or for the customers, they need to choose the property inverters for his home or for any places they need to use this system, right? So if the if their house their home usage is only normally some small things like only lights, only refrigerator, only the few the AC air conditions. So you can choose like high frequency. If you have some bigger load, you might be need to choose the low frequency. Okay, like first one, power frequency is isolation transformer. This is the inside of the. It's built in inverter is inside of the inverter. Okay, the transformer usage only the power frequency have. Okay, high frequency don't have. So why I need this one? Because the transformer is very heavy. It will be make the same power like both low power frequency and low high frequency inverter both 5 kVA, but power frequency is bigger than high frequency because it has a transformer inside, bigger and heavier. Okay, because here impactive resistance, this one, the performance of the power frequency is better than the high frequency. For example, you have a small water pump, or your air conditioner is little big, like bigger than 2 or 3 HP. So in this type of situation, you'd better choose the power frequency, not high frequency. Okay, and lithium battery activation here means, as I said, wake up the or activate the battery, lithium battery automatically. Power frequency now all can support this function, but high frequency only IVEM. Okay. From the controller, power frequency has the also have the MPPT, but only IVPM have the MPPT controller. IVPS don't have the MPPT controller. And the high frequency you can choose MPPT or PWM. It's both have the different type of mode. Okay, and weight and size, from the weight and size here, power frequency is heavy and the high frequency is light, lower. Efficiency, from the heavy efficiency, high frequency is higher than the power frequency. Parallel, both can support. High frequency has a 5 kV, high 5 kV can parallel, and power frequency is 10 kVA. We already shared this. Okay. So this is the introduction of the high frequency and low frequency, and also I made a simple differences or compare my hotspot. Okay, okay. Now we have how many people here? We have 9. Okay. Um, I need to repeat this again. Sorry, we just I think previously my internet lost again. Okay. So next step, let's doing the parallel installation. In installation, how to say, the kind of training or remind. Okay. Here, first step is mounting inverters and batteries. Inverter distance you need to be careful is during 20 to 50 cm. Okay. And step 2, connect the AC input, AC output, parallel connect communication cable, and current sharing cable. Okay, please make sure AC output combined and same battery group. Okay, and step 3, double check cable connection. Make sure all cable tight and correct. Means that after you complete step 2, please have double check of the double check the cable connection. And step 4, turn on battery and do inverters parallel string setting on the program 28. This one is you can set these single phase parallel or 3-phase parallel. Okay, and one by one individually. Okay, and step 5, keep battery group on, turn on inverters one by one. Confirmed all inverters output normally. Means after you've finished complete step 4, and then you can turn on all the inverters one by one. Step 6, turn on AC input and PV input one by one. Right, so previously only turn on battery, right? So now you can turn on the AC input and the PV input, and also the turn on the breakers. the output because you can turn it on, supply to load. It's okay. Okay. So all this is the steps. And here I make a, how to say, a short the diagram connection program. Like here, this is the first step, mounting all these devices, like inverter. Hello? Okay. First step is mounting the inverters and batteries, or first, mounting first. And here I showed here this one. This is the DC switch. Every inverter has one DC switch. But as I know, in the real installation, I think many of you don't install this one. But from us, we suggest you install this one for safety. Install the DC switch, and after you mounting all this done, and then you can connect to the AC output. This output. This is three phase. Okay, you can see here three phase. You can this two one is one phase. This two one is one phase, and this two one is two is a last phase. Okay, it's a cable connection, and then here is the current sharing and communication, parallel communication cable, one by one. This, okay, and this part communication you can refer the user manual how to connect this cable, and this is battery, okay, battery connection. Battery accepted the accepted this positive negative connection, but also here you can see this is has um, the this one is a blue one, blue cable. This is the battery communication, battery communication cable. So all you can see all these batteries, they have the communication cable to make sure all these how to say communicate with each other. And here this one has the combined or parallel communication cable, not communication cable, sorry, the positive and negative cable, to make sure these this group is a complete group, is combine all of them. Okay, so no matter the battery or the output neutral, you can see here neutral, neutral, the blue one neutral, neutral, all combined together. Okay, and also this one same. So after you complete all this cable connection, then last step is you can set the parallel mode on the battery. You can turn on this one, then set P1, and then after this done, after this first one set done, then off this one, then turn on this one, then turn on set P1 in the program 28 set P1. Okay, then after done, then off this one. This means one by one individually. Okay, the third one also same, turn on and set P2, and after done, then off, then P2, then 3, P3, P3. So this is the three phase. How do the parallel connection? Okay. So you can see here, this one red is COM. COM means the communication cable, and this current sharing. You can see here during P1 and P2, there's no current sharing cable. Only same phrase, P1, P2, P3. Only same phrase has the current sharing. But all these inverters must have the communication cable. Okay, is attention this part. Okay, so communication cable, combined neutral and combine all the batteries. So all these points is very important. And next is the single phase parallel. First step same, connect all the AC and battery, but here only use single phase. You can see here all the L, output L same, output N combined. So this is output AC and the battery, and then the communication cable and current sharing. You can see this is communication cable, current sharing. See, because this is single phase, so all inverters as one phase. So both communication cable and current sharing cable must be connect each other. It's different with the previous one. See this one, this different phase, no need current sharing. But here, same phase must connect all these cables. Okay. Then the battery connection, battery part same. Battery part both positive, negative, and the communication cable all must be combined. Okay. And then it's same. Set the PARA means the single phase in the pipe program 28 same. Set PARA or set PARA. This is a software set. So after all these sets, then you can turn on the battery one by one. Battery switch one by one, then turn on the inverters. Okay. Then last step, if the output is no issue, then you can turn on the PV input, turn on the AC input, then the parallel system is done. Okay. So here is showing if you don't know how to do the parallel installation, you can follow this video and follow these steps. Okay, follow these steps. Okay, step 1, step 2, step 3, step 4, 5, 6, and refer the user manual. I believe it will be if you follow all these steps and check the user manual carefully. I think it would be not any mistake. Okay, so this is the today's inverter part introduction. Okay. If you connect the two inverter in parallel with it, make AC output to be more than if you connect two inverters in parallel, where to make AC voltage to be more than. No, 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 no. Why you asking like this one? If you connect two inverters in parallel, means it's only extend your output power like two pieces 5 kVA. If you parallel them, then your system become 10 kVA. Okay, but output still 22 volt AC. Okay. So the introduction part we finished. Now is the Q&A time. If you have any questions, you can ask here. I can reply you and answer you. Only extend our system power. Like if you have two piece 5 kVA, then system become 10 kVA, but AC output still okay. You have any other questions? Hello. Anyone has questions? You can ask it here. If you have any question, please feel free to ask here. How you can make it as three phase? Three phase. We just showed you this one, like this system, three phase. See, okay. Three phase. At least you need the three pieces inverter. This here I just show you six piece, but similar. Okay, three phase. Uh, Cable connection, AC, uh, output, battery, all these. And here this is the communication, current sharing cable. Okay. Here, this is battery connection. Combine all of them. Okay. So actually, I already explained the details, all the details previously. So you can follow these steps. And this training I will show in YouTube in the Felicity channel. So you can double check this installation again, how to install the and doing the program setting. Yes, you can set as 211. Any question? For three phase, we don't need to contact in all three inverters. We need to connect parallel connection. Um, no. For three phase, in three, if you only have three inverters and you need to combine, you want to connect the three phase, so you need to connect the uh, communication cable. Must connect current sharing cable. No need. Actually, I can show you the um, user manual. Like see here, this one, for example, this is the IVPM IPS three phase. You can see this one P1, P2, P3, and here the communication cable connection. This one only connected the communication cable, but the current sharing part, this one, this part, didn't connect. So the communication must be connected, but the current sharing is no need for the three phase, and each phase only one piece. Okay, understand? Any question? But here I need to emphasize again, before you turn on the inverter and set the parameters, the parallel parameters, you have to make sure all neutral is combined and the battery also use the same one. Okay, battery group use the same battery group. Okay, this is very important. Each one of the three inverters will be need to PV or only one. Uh, I guess you're asking, can you combine all the PV inputs and then separate to connected to the each inverters? It's no. PV inputs must be independent. Means you have three phase, right? No matter it's three phase or single phase, you have different inverters. So the different inverters PV inputs must be independent. Okay, you cannot combine all the PV strings and then separate them with different cables, then connected with the inverters. No, it's not allowed. It. Okay, PV input must be independent, no matter it's single phase parallel or three phase parallel. It depends on the inverters MPPT capacity. Like it depends on inverter MPPT controller. Some can, some cannot. This one about the panels layout is no matter with the it's no matter with the single phase or three phase parallel. No, it's only matter with the inverter's specification. Okay, like for example, we can go back this one. We can go back this one here. For example, um, if you have one type of panels like you have the VOC is 45, for example, one piece. Okay, and for IVEM maximum you can connect 10 or 11 maximum piece for one string. For one string. Okay, but if you use same panels connected with IVCM, you only can use how many? Like only three piece. I think three piece because 45 multi 3, so is 135 volt. So it's approach 145. So for IVCM maximum one piece. One string only three piece. Three piece. Okay. So see, IVM can 10 piece, but this one only three piece. So it's depend on the different MPPT specification. So you need to confirm this. Okay. About these parts, we can This part we can doing more training in the system training part. Today, this part we are mainly talk about the only talk about the inverter. Next time we can training the system installation or system design. How can connect the four 10 kV lithium battery to four inverters? Four-piece 10 kV lithium battery actually is little. The power is small. It's too small for the four-piece 10. Okay, it's small. It's too small. That's a eight-piece lithium battery. Okay. Next time we can talk. We can. Next time I can introduce more. Oh, sorry. So we can talk more with the system design. How to choose inverter, how to select the battery, how to lay out panels. Okay. Any questions? If do not any questions, we will finish today's training next time. Okay. Thanks for coming and welcome next time training. Okay. So see you next time.
Felicity Solar makes life full of hope.